So good morning everyone. Welcome to the 7th lecture of this course, and the topic that I'll discuss today is subtraction of non-decimal numbers. In the last lecture I discussed with you the addition of non-decimal numbers. In the last lecture I discussed this topic, addition of non-decimal number system, and I told you that if at any point if the sum of 2 or 3 or n numbers exceeds the largest digit number, then you will have a carry. That's all. And how to find carry and this with the help of division. Now let's come to the subtraction of non-decimal numbers. Of course decimal number you know, but again I'll explain this by decimal numbers only. First, taking reference as a decimal number. So how do you subtract two decimal numbers? Just try to understand this first. This we know very well, how you subtract two decimal numbers. That suppose you have a number, suppose I say that you have a number 45 and I say subtract 13 from it. This is base 10 and this is also base 10. Now there are two numbers. This is the number to be subtracted and this is the number from which this 13 has to be subtracted. This is called minute and this is called the subtrahend. And when I subtract these two, this is called the difference of these two. Now I simply, how I subtract this? 5 minus 3 is 2 and 4 minus 1 is 3. This is the resultant. This is the final answer in base 10. This we already know, as simple as it is. Even class 1 child knows this. Now suppose I take another number. Suppose I say that you subtract 46 minus 27 in base 10. Normal numbers, how you subtract this? I say subtraction of these two numbers. Now observe one thing. Of course unit number, this unit digit is to be subtracted from the unit digit, 10 digit subtracted from 10 digit and so on. This is what we follow. So if you see that the 6 is more than 7, so what I do, I take a borrow from here. I take a borrow from here and the value of this borrow is 10, and here you will have a number 1 less than this number once you take a borrow from here. And now it is 10 plus 6 is 16. 16 minus 7 is 9. 16 minus 7 is 9 and 3 minus 2 is 1. This is the answer in base 10. So what is the concept here? If you see, look at the concept that I'll apply in all number systems is that if this minute is greater than subtrahend, then naturally you subtract it directly. Okay, but if this number is less than the number which is to be subtracted, then you take a borrow and the value of the borrow is equal to the base of the number and you add that base to the number and then go for subtraction. What have you done here? At this stage, if you see, you have done 10 plus 6, which is the value of borrow, and minus 7. The 16 minus 7, this is what we do. Now let's come to the subtraction of non-decimal number systems. It can be octal number system, it can be binary, hexadecimal, or any arbitrary base. So let's take an example. Suppose I say that subtract two numbers. Let's start with octal number. Suppose I say you subtract number 7, 5, 6 in base 8. This is a number in base 8, and subtract say 2, 6, 3. This is also in base 8. Let's take an example and I want to subtract this. This is my first example for the day. This is example 1. This is an example here. Now I'll go for subtraction. Just see how will I subtract these numbers. First of all, of course the unit 10, 100, unit will be subtracted from the unit digit, 10 from 10 digit, 100 from 100 digit, and so on. Means first digit subtract first digit, second to second, third to third, and so on. Now the 6 is more than 3, so I simply subtract this. 6 minus 3 is 3. Remember that octal number understands only digits from 0 to 7. Now 5 is more than 6. This 5 is more than 6. So what I do here, just simply I borrow one digit from here, and here your remaining digit here will be 6, and the value of this borrow is equal to the base of the number, so it will be 8. Value of this is 8. Now 8 plus 5 is 13, and 13 minus 6 is 7. I hope that this point is clear to you. This 5 is more than 6, so I take a borrow, and when I take a borrow, this number is decreased by 1. So it will be 6 here, and the value of the borrow is equal to the base of the number. This base is added to this minute. 8 plus 5 is 13, and 13 minus 6 is 7. Now 6 minus 2. 6 is more than 2, so 6 minus 2 is simply 4. And this is my final result. In base 8, I can say that this is my answer here. I hope that this is clear to you. Let's take some hexadecimal subtraction, for example. I say that you subtract two numbers, say A 5, B 6, and suppose I say another number, suppose 7, 6, F and A. I say subtract this. This is in base 16. Remember that again same rule applies, that if you want to do any mathematical operation, the base of the numbers must be same. So if I have to subtract these two numbers, see how will I subtract this? Keeping in mind that you have in hexadecimal numbers, A corresponds to 10. If you remember, repeatedly I am telling you, this A corresponds to 10, B corresponds to 11 in decimal, C in hexadecimal corresponds to 12, D is 13, E is 14, and F is 15. You must keep this in mind. Now look at the problem. It says 6 minus A. Look at this term, 6 minus A. A corresponds to 10. See what I am interested in. I am interested in this. Look at this part only. 6 minus A. I am interested in this 6 minus A. So 6 minus A. I am interested in this actually. And you have a term here also, B. Now this 6 is less than A, so I have to go for a borrow. So if I have to go for a borrow, naturally here this digit will be one less than the original, so this will be A. This 11, one borrow, and the value of the borrow will be the base of the number 16. So 16 plus 6 is 22. 22 minus A means 10. What we are doing here, it is 22. If you see, this is a borrow is here of value 16. So 16 plus 6, 22. I am doing 22 minus 10 because A corresponds to 10. Now 22 minus 10 is 12. 22 minus 12, 10 is 12, and this 12 corresponds to C. So 16 plus 6, 22. 22 minus 10 is 12, and 12 corresponds to C, or 10, 12 in decimal is equal to C in hexadecimal. Now A, let's come to this part. Here it is A. A is 10 and F is 15. So again this is not directly possible. What I need, this is less than F. This is 10 and this is 15. So I need a borrow. From here it will be a borrow. And what will the value of this borrow? If I take a borrow, here you will have 4. Now value of borrow is 16. So 16 plus A. 16 plus A means 16 plus 10, that is 26. 16 plus A, this value will be 26, and 26 minus F. 26 minus F means 15. 26 minus F means 15 here, and if I subtract these two numbers, the value is 11, and this 11, it corresponds to B. 11 is equal to 11 in decimal is B in hexadecimal, so the value of this will be B here. Now 4 minus 6, again this 4 is less than 6. If this 4 is less than 6, naturally I need a borrow. When I take a borrow, this number will be decreased by 1. So 10 remaining will be 9 here. Now this is 4. I take a borrow and the value of a borrow is equal to the base of the number, that is 16. So 16 plus 2 is 20. If you see here, it will be 16 plus 2 is 20. And what I have to do? 20 minus 6. Not 16. It is 20 minus 6. 20 minus 6 is 14. And 14 is E. 14 is E. So I write down this E here. Now here it is 9, and 9 minus 7 is 2. So this is my final answer. Subtraction of this digit and this digit is equal to 2EBC in base 16. You can go for a cross check also. You can, this plus this should be this number, and that will be a revision of your non-decimal addition also. You can do this on your own. It's a homework for you. Add this and this, you should get this number. Add this and this, you should get this number. Means your answer is correct then. Let's take binary number for example. Let's take any binary number. Suppose I say next example. This. Let's take another example here. Suppose I have a number, say 11011. This is in base 2. And suppose I say that subtract this 10111. Let's take it this way. This is in base 2. I say subtract this. There is a binary number which understands only 0 and 1, and the value of borrow will be the base of the number, means the value of borrow is 2. So see, 1 minus 1, these are equal. 1 minus 1 will be 0. Of course, equal numbers, difference is 0. 1 minus 1, again 0. Now what will happen here? Look at this part. This 0 is less than 1. It means I need a borrow. I need a borrow. From where I take a borrow, that number is decreased by 1. So 1 minus 1 will be 0. This will remain as 0. And the value of this base, this borrow, the value of this borrow is equal to the base of the number. It means that the value of this borrow is 2, and 2 minus 1 is 1. This 2 minus 1 is 1. Then 0 minus 0 is 0, and 1 minus 1 is 0. So this is my final answer in base 2. I hope that this is clear to you. This is my final answer in base 2. This is how you go for subtraction. Let's take another example. Let's take, I've taken binary number, octal number, hexadecimal number. Let's take a number with any arbitrary base. For example, suppose I have a number in base 9. Base 9 means you have digits from 0 to 8. So suppose you have a number 8, 2, 5, 3, and suppose I have another number. Suppose I say 5, 4, 6 and 7. Suppose I take these two numbers, and these two numbers are with base 9. With base 9, both of them have base 9. Now how I subtract this? Just see. Again, this 3 is less than 7. This 3 is less than 7. So I need a borrow from the previous bit, from the previous digit. So when I take a borrow from previous digit, that digit is reduced by unity, by one number, one digit, by 1. Okay, so this will be 4 here, and the value of this borrow will be equal to the base of the number. So the value of this borrow is 9. Value of this borrow is 9. So 9 plus 3 is 12, and 12 minus 7 will be 5. 12 minus 7 is 5. Now further I come to this digit has to be subtracted. This digit has to be subtracted from this digit. 4 is again less than 6. So I need a borrow, and when I take a borrow from the previous digit, it will be reduced by 1. So here you will have 1. And look at this. Again the value of this borrow will be 9. And 9 plus 4 is 13, and 13 minus 6 is 7. 13 minus 6 is 7. Then let's come to this digit, third one. That is 1 minus 4 cannot be done directly. This 1 is less than 4. So again I need a borrow from the previous bit, and here from where I take the borrow, that digits will be reduced by 1. So it will be 7 year, and the value of year, look at this, I'm interested in, I'm taking a borrow, the value of borrow is 9, 9 plus 1 is 10, and 10 minus 4 is 6. 10 minus 4 is 6. And here, just see here, 7 minus 5, this is a subtraction here. 7 minus 5 is 2. So this is the corresponding number in base 9. I hope that this is clear to you. Now, suppose you have two numbers with different base. I'll not solve this problem. It's a homework for you. That suppose I say that you have number 8463. I take this number. There's a number in base 9 minus, suppose I say subtract 1, 2, 5. That's all. Suppose this is a number in base 7, and I say what is the corresponding number in base 9. It's a homework for you. I have done this type of problem with you with addition. All you have to do, since the result is asked in base 9, so you have to convert this number into base 9. The approach I am telling you, you convert this number into base 9. How? First convert this into base 10 and base 10 to base 9, and then subtract these two numbers and find out the difference between these two. So I hope that this subtraction of non-decimal numbers is clear to you. Let's come to another article, that is the multiplication of non-decimal numbers. So let's come to multiplication. If you know addition, then multiplication is quite simple. Next article is multiplication of non-decimal numbers. History. I'm writing only, okay, let's start multiplication of non-decimal numbers. I'll start with this. Let's take, suppose I need octal multiplication. For example, suppose I say multiply two octal numbers. Again, that rule applies everywhere, that the numbers must have same base. Suppose I say that multiply simply, I say 72 in base 8. Multiply this by 6. Of course, this 6 is in base 8. The 6 is also in base 8. Now, all the calculation that I do, is with respect to decimal numbers. But I'll have to convert this. Now, 6 to the 12. What I am doing here, 6 to the 12 is decimal. So 6 to the 12, what I do, I convert this 12. See, this 12 is in base 10. This 12 is in base 10. All I have to do is I have to convert this base 10 into base 8. So how I convert this decimal number to any other? I divide this by the base of this 12. 8 1 ja 8, remainder is 4. So this corresponds to 14. Means 6 into 2 is 14 in octal. 12 in decimal, but it is 14 in octal. And how I write 14? This is 4 here and a carry 1. And a carry 1 here. Now, either you say that you multiply this or you add this. So now 6 7 ja 42. Look at this term. It is 6 7 ja 42 here. This 42 is in decimal. What multiplication I am doing in my mind, what I know is decimal, not octal. So what I do, I simply write it here, 42. So now I'll convert this 42 into octal. I'll find what is the corresponding octal number of this number 42. So I'll divide this by 8. 8 5 is 40. Remainder is 2, and I write this here. So 42 corresponds to 52. So this is 52 and 1 carry is here. So it will be 53. 52 plus 1 already carry was there. So it is 53 and the result is 5, 3, 4 in base 8. A very simple cross check you can do, that you convert this number into base 10, you convert this number into base 10, multiply, do the multiplication in base 10, whatever result you obtain in base 10, see that the corresponding result in base 8 matches with this result or no. I hope that what I am trying to say is that, again it's a homework for you. You convert this into base 10, convert this also into base 10 and do the multiplication. You'll get some number in base 10. Convert this resulting multiplication in base 10 into base 8. If you get the same result here, means what calculation you have done here, what operation you have done here is perfect. I'll continue with this topic in the next lecture. So thanks for the time being.